Hi there, so this is a calculation practice video. So this one's for force, mass and acceleration, so F equals ma. So the equation that we're going to be using, if you can't remember, so resultant force, and that's really important, the resultant force, is equal to mass times acceleration. Okay, so the resultant force is measured in newtons, mass is measured in kilograms, and acceleration is meters per second squared. So I've got 3 questions here to go at, and then I'll go through the answers, and then after this I've got 2 more bit more challenging questions for you to have a go at, and then I'll take you through those answers as well. So I'm going to rub this out, so I'll get this down and then pause the video and have a go at the questions, and then I'll take you through the answers. Okay, so let's look at this first one. So number 1, a resultant force of 0.130 newtons acts on a toy car and causes it to accelerate at 11.1 meters per second squared. What is the mass of the toy car? I'm not sure how realistic these numbers are, but here we go. So F equals ma. Oops, I don't want to be using that one. F equals ma. So force is mass times acceleration. So rearrange to find mass, so I need to get rid of a times a. So to obviously get rid of a times a, we need to divide by a on the other side. So the mass is simply the resultant force divided by the acceleration. So the resultant force is 0.13 divided by an acceleration of 11.1, which gives us a mass of the toy car of 0.0117 kilograms. I suppose we could times that by 1,000 to get that into grams. And that would give it an absolutely massive 11.7 grams. I'm not an expert in toy cars, but it doesn't seem a lot. It's a big acceleration though. Remember, gravitational acceleration on the surface of the Earth is 9.8 meters per second squared. So look at the next one anyway. So resultant force, so this time we've got 6.79 newtons, acts on an object and causes it to accelerate at 1.2 meters per second squared. What is the mass of the object? So same again. So it's F equals ma. So we just need to rearrange to find mass. So the force is force divided by acceleration gives mass. So 6.79 newtons divided by acceleration of 1.2. So that gives us a mass that's equal to, you should have got 5.7 kilograms. If you find these quite easy, the questions that are coming up afterwards are much more challenging. Anyway, this one if you want to check. So resultant force of 3.14 newtons acts on a toy car of mass 0.447 kilograms. And this time we need to rearrange to find the acceleration. So we need to get acceleration on its own, make it the subject. So we need to get rid of a times mass. So to do that, we need to divide on the other side. That'll give us the acceleration. So force is 3.14 divided by the mass 0.447, which will give you an acceleration of 7.0 meters per second squared. Okay, let's do some more challenging ones. Okay, so if you want to pause and have a go at these two, and then in a few seconds I'll start taking you through the answers. By the way, if you're struggling with these, you might, a small diagram might help. So let's have a look at this one. So a driving force of 100,000 newtons, so 100 kilonewtons, or kilos are 1,000, so 100,000, acts on a small plane of mass 1,500 kilograms, and there's air resistance which has a value of 25 kilonewtons. What is the acceleration of the small plane? So remember the equation F equals ma. F is the resultant force. So if a free body diagram might help. If you could either draw a plane, or you could just pretend that dot is the plane. Anyway, so I'll do that. So I'll try to keep this as neat as I can. So we've got a driving force and we've got a resisted force. So the driving force is equal to 100,000 newtons. So you could do 100,000 like this, or you could do 100 times 10 to the 3 if you've done standard form. So 100,000 newtons. And backwards is 25 kilonewtons, or 25,000. Or 25 times 10 to the 3. It's completely up to you. 25. I'll do it like this time. Newtons. So in this instance, what is the resultant force? Well, if I've got 100,000 to the right, we'll take that as positive. That's the direction it's traveling. The 25 newtons to the left, we'll take that as negative because obviously it's in the opposite direction. So the resultant force in this instance, we have to subtract them. So the resultant force is 75,000 newtons. And it's that 75,000 resultant force that will be causing the plane to accelerate. So now we can use F equals ma. And we need to rearrange to find acceleration. So that would be force divided by the mass. So the resultant force is 75,000 divided by the mass, which is 1,500 kilograms. So that gives us an acceleration of 50 meters per second squared, which is pretty outrageous. That's 5 Gs, so it's probably a fighter jet. Let's pretend it's a fighter jet. Okay, right, last one then. So we've got a car. So this car's got a mass of 1,500 kilograms, and it accelerates at 3.5 meters per second squared. Now this is a tricky one. It says the combined frictional force and air resistance is 3,000 newtons, and we need to calculate the driving force of the engine. So I'll do a body diagram. So this is my car, and we've got a frictional force of, so put that into the left, of 3,000 newtons. Now we need to find the driving force, whatever that may be. So we can calculate the resultant force by simply using F equals ma. So the resultant force is the mass, which is 1,500, times the acceleration, which is 3.5 meters per second squared. So if we calculate that, that gives us a resultant force of 5,250 newtons. And if you said that that was the final answer, that's wrong. That's just the final force after we've done the driving force minus the frictional force of 3,000. So our force, or should I say the resultant force, 5,250, is the result of that. So we would have to do our force, the driving force, subtract the 3,000 Newton frictional force to give us our resultant, which will be the 5,250 newtons, which we just calculated. So as you can see, to get the frictional force, we'd actually have to, take the minus 3,000 to the other side. So we'd have to do 5,250 plus 3,000. So that gives us a driving force that's equal to 8,250 newtons. And if you got that, really well done, because that's quite tricky. If you didn't get it, you might want to rewind and have a go at the questions again. All right. Anyway, thanks for watching, and I'll speak to you soon.